Alright, good afternoon everyone. Welcome to today's Sec 4 E-Math lesson with me, Teacher Jason over here. As usual, same time slot, same day. Let's see what we are expecting. Alright, so let's get on to the lesson proper, with me appearing at the bottom corner again. Alright, so let's get started over here. Just some general rules, be patient and understanding along the way as I'm going through certain questions. Observe gracious and respectful behavior even in digital space. So as you're typing, even though only I can see your message, but just be respectful in terms of what you're typing. Alright, lastly, ask good and relevant questions for today's content. So what are we essentially going through today? Okay, again, further revisions, but we are focusing on probability. In fact, for single events and for combined events. Again, the few diagrams you need to know, the possibility diagram, the tree diagram, and what happens with this key thing over here, with replacement or without replacement. How do they matter? Okay, so let's get started. Before that, let's revise on probability before we get on to our first bubble question for today. Okay, so when we talk about probability, suppose we are looking in this case for our event here E. Okay, what is this meaning over here? It means if you want to find the probability of this event E, given all the possible outcomes that we have. Okay, we want to find the ones that only helps for event E. That only helps for event E. So in this case, there are few situations where event E can happen. So one, if event E is definitely going to happen, we call it a confirmed event. Okay, what do you think the probability is? It definitely happens. So what is that number that we are looking for? Can anybody tell me? Very good, Chen Zheng. Very nice. Okay, we know that number. Very good, Nguyen Sang. Very good, Denise. All right, we know that number is going to be 1. Okay, definitely happening. But let's say if it's possible, that means I know it's going to happen, but I'm not sure it is definitely happening. So in this case, you realize it's a range of values that we are looking for. So what is that particular range that we are looking for? Very good, Nguyen Sang, but take note of your inequalities. Okay, that is not the way we describe it, but I think it's just a typo. Don't worry about it. Very nice. Anybody else wants to try? Okay, so we know it's a range, so P of E should be in the middle. And then we have the inequality sign over here. And henceforth, we know, okay, we know it's going to happen. So in this case, it cannot be 0. It cannot be 1 because we are not certain. So that's the inequality. And henceforth, if it's not possible, the number has been said already. Can anybody tell me what is that number we are looking for? Okay, so just a refresher. Okay, if it's confirmed, what? I definitely know it happens. It's a 1. So impossible, example, the probability that Singapore is going to snow. It's not possible, right? Yes, Denise, that's right. Okay, it's 0. And let's say if I want to find the opposite of event E. So in this case, the probability of Singapore not snowing. So suppose E is the probability of Singapore snowing. Not snowing will be the other way around. Okay, take note, it's the opposite. So it's going to be 1 minus the event happening. So these are the few things that you usually will work with for the first part of probability. Okay, so now going to that, let's move on to our first bubble question. Okay, so this is a way whereby, okay, you have to read the question very carefully over here as such. So some gold and silver bronze coins not given. Okay, all the details really true. Let's see how you will fare. Okay, in this case, there will be 2 bubble questions that are linked together. First one, pretty quick, 1 minute. Launching the bubble launcher in 3, 2, 1, let's go. Alright, this should be pretty quick for you guys. Let me take a look at the response. Alright, okay, looking at the response, this should be quite okay. Let's see. Over here, let's take a look. Okay, look at the question. Okay. I think I will let you have some silence and let you all try to solve it yourself. Okay, seeing the response, looks good. Looks good to me. Looks clear to me as well. Perfect over there. Okay, you have the last 30 seconds for those who have yet to answer. Quickly respond it as quickly as you can. Okay, this is a standard kind of question whereby you should get the content from there. But again, if it's not sure, I will still go through. Okay, we have 10 more seconds. Take note. Look at the responses clearly. Last three. Okay, alright. I think most of you nail it down. That's good. Okay, but take note. Okay, some of you have answered this a little wrongly. So let me just go through it for the benefit of doubt. Okay, so take note. Looking at the numbers, when I say gold coin respectively, this refers to this, and silver coin here refers to this. So you have to get the numbers. Now, bronze coins, if I take a look at bronze coins, that means it's neither gold nor silver. So you have to consider these two scenarios over here. Some of you only subtracted only one scenario, so take note. In this case, probability of a bronze coin, be it's where the event I choose a bronze coin, it's going to be just 1 minus probability of a gold coin minus silver coin. And once you have that, plug in the numbers. Gold coin is going to be 0.25. Silver coin is going to be 0.4. Take these two over here, subtract them, okay, referring to them accordingly. 0.25, 0.4, subtract them accordingly. This is going to give you my number, 0.35. Okay, standard type of question that you will encounter in terms of probability, therefore 3 is the answer. Alright, so seeing that, I hope for those who make the mistake, you are a bit clearer now to consider every situation when you do complement. Very important. But now, bubble question number 2 is the tricky one over here. It's the tricky one. Take note, Denise, let's take a look back over here. When we are talking about this event over here, okay, is it possible to have a gold coin and silver coin at the same time? Because I'm picking one event, right? Gold coin and silver coin. Is it a possibility for me to pick both at the same time? When I talk about probability of gold times probability of silver, that means both have to occur at the same time, right? Yes. So essentially, you're considering only either gold or silver or bronze. They are, in this case, mutually exclusive. So that's why you can't do that. So when you talk about times, which I'm going to go through later when it considers multiple events, okay? Times means n, plus means or. So each one of them are individual events. So based on this question, you have to think about all the different possibilities. Okay, I hope this is a little bit clearer, Denise, before I move on to bubble question 2. Okay, so I hope once with that, this question, it's a little bit harder in the sense that, how do I relate this information, of course, silver coins, then gold coins. Okay, let me use a different color. How do I relate this information to the ones that is shown here? So let me use the same highlighter. Gold coin, 0.25. Silver coin, 0.4. Okay, now how do I relate all this information to B? Okay, very important. Alright, launching my bubble launcher in 3, 2, 1. Okay, this is a little bit tough. Let's go. Let's see how you guys fare. Okay, wow. Okay, either you have super magical powers that you guys are doing so well, or in fact, you might have attended the previous lesson, but then again, I will try to re-explain in another manner, even though you might have attempted. Again, doing good over here. We are over here for the positive vibes. Doesn't matter whether you got it correct or unsure. Try to answer it to the best of your abilities. But wow, you guys are doing so well. That's so good to hear. That's so good to see. Okay, we have about 1 minute left. Okay, again over here, this concept, it's about single events over here. Alright, so then again, let's see how you will fare. Single event, so the and ors don't really matter. For this case. Alright, 1 minute left. Alright, looking at the responses, you guys are doing so well. Okay, but then again, I'll take my time to explain along the way, alright? I'll take my time to explain along the way. "30 seconds left. For those who have yet to respond, try to respond accordingly. Last 20 seconds. Last 10. Last 5. 4, 3, 2. Alright, I would say about 90% of y'all got it down. That's good. But for those who did not get it correct, let's see how we fared. Again, okay, this question, when we try to link to probability, now how do you know 0.4, 0.25? These are numbers, or in fact, the word probability comes into play. Then you may ask, how do I relate this to probability? Now, when we talk about probability, we talk about in fractions, right? Okay, so the number here, 0.4, is the silver coin, 0.25 is the gold coin. And it makes sense because to have a higher probability, it makes sense to have more silver coins than gold coins, right? Okay, that's the first thing I have to understand. It makes sense to have more silver coins than gold coins. So, what it is trying to say is, okay, if I were to translate it, how do I convert this sentence to make use of probability over here? That's the first thing, because you're given probability, and over here, this sentence over here is not a probability sentence. Or in this case, not making use of probability yet. So how do I translate this to the probability sentence? Okay. Now, I have 12 coins. What is the question asking you? Finding the total number of coins. Is it given to us? Well, there's no way saying that I can make use of total number of coins. So one trick is this. If it is not given to you, learn this in Sec 1, or for those who follow my Sec 1 lessons, okay? Or in fact, it's okay. But this is a trick I can share to everyone, not only in Sec 1, but for the rest as well. We let it be a variable. So from here, if I were to say let x be the total number of coins, is there any way right now I can translate this sentence to a probability sentence? I'll give you 1 minute to think about it before I write down. How can I translate this to a probability sentence? Anybody wants to try? Or in fact, I have most of you got it right. So how do I translate this? Okay, so I know the total number of coins is X. So that means gold, silver, and bronze is X. So if there are 12 more silver coins and gold coins, I know the total. Can I then say, very nice, that's good. Okay, I think you got it down, Chen Chen, that's good. Okay, but there's a lot of working process behind, so it's going to be a bit hard. But translate it down. Can I say, since I know the total number of coins, the probability of getting silver coins is more than gold coins by 12 over X. Now, how do I translate this sentence? Very good, Chen Chen. That is essentially the sentence over here. Because to get from this step, essentially, suppose, okay, the probability of getting silver coins, we don't know, okay? We don't know the number of silver coins, that is not known. But suppose we know is S over X, okay? And the probability of getting gold coins, we don't know the number, so it's going to be G over X. Say for example, okay, translating this, okay, this is essentially, take note, this is the probability. We do not know the number of silver coins. We do not know the number of gold coins, but this is given to us. Take note, this is essentially the yellow color one. This is essentially the green color one. If I subtract them, isn't that essentially going to give me the difference of coins? And the top actually shows the more part. Okay, so there is one intuition that we get there, and therefore we can put in our numbers. 0.4 minus 0.25, which Chen Chen has essentially shared. Once you get this down, that's where we build it up, 0.15. Now, some of you actually selected the fourth option because that one is just number of silver coins, okay? That is not what we want. We want total number of coins. So 12 over 0.15 It is essentially the first part that is hard to grasp, the yellow color part. But once you get that, you realize, oh, x is equals to 80. That is why I get number 2, which is very good. Most of you got it down. That's good to hear. But for the rest, if there's any queries, okay, feel free to ask. I'll give you all 1 minute to ask ahead before I move on to the first work example. In this case, for multiple events. Okay, or in this case, maybe it's easier for me to say 1 if you totally understand, 2 if you're unsure, 3 if you totally do not know, and you would want me to, and yeah, if you would want me to try to explain again, okay, but in this case, if I can explain in a while, okay, that's good, okay, I have a 1.9, okay, that means it's roughly half, smiley face, okay. The thing is, I'm scared it might crash, but let me try, okay? Let me try. Since you have asked for it already, let me initiate the feedback then. Okay, that's good to see, all right. For those under the red part, okay, there's a little Q&A, or you might feel free to ask me what if you're unsure of. Okay, that's good to see, okay. So let me try to summarize what I'm saying here for the red part, okay. If not, during the Q&A, I will ask again. So what happens is this. First things first, what we are only given is the probability, 0.4, 0.25. But now what happens is this, okay? We are only given the probabilities. This is not a probability sentence. So what we need to do, we need to convert it to sort of like a probability sentence so we can use this part. What are we finding? Total number of coins. Usually what we don't know, we let it be an alphabet. Alphabet already, what happens? Okay, now, given this, let's try to convert this sentence to a probability. 12 more silver coins. 12 more to the total is saying 12 over x, the probability of getting a silver coin is higher. And how is it higher? 0.4 minus 0.25. That's what it translates down. Okay, that's what it translates down. Okay, so this is how I get this thought process. Okay, I hope this is a little bit clearer. If not, yes, there's a lot of alphabets, that's right, but this is the understanding. Okay, thought process is this. You don't have to write this down, but that's where we have to backtrack. If it's unsure during the Q&A, I'll try to answer it accordingly. Otherwise, if not, I will try to proceed. During the Q&A, we can proceed on to bubble question 2, okay? Because there are quite some questions I need to ask ahead, so apologies for that. And yes, Isabel, I usually don't use the feedback function because it's not really refurbished for high student count, but for this, I guess I'll use it. Okay, thank you for the note, Isabel. Okay, thank you for the note. Now, next up, work example 1. These are the kind of questions that will usually start to pop up for you guys in the table form, whereby you have to decipher, okay, what information do I need to use? In this case over here, let's take note. 2 students are selected at random. Based on this sentence over here, can anybody tell me, will this be with replacement or without replacement? Will this be with replacement or without replacement? Alright, very good, Ophelia. Anybody else wants to try? With replacement or without? That's the first thing you have to know before we head on to this question. Alright, very good, Chen Zheng. Very good, Din Tuan. Very good over here. So we do have a consensus that this is without replacement. Now, that's where we have to get to the notion over here. Find a probability that both students are right-handed. So when we talk about both students, we are talking about male and female. Now over here, we want to take a close look. We are looking only at right-handed. Okay? We are only looking at right-handed. So in this case, therefore, to find out both students are right-handed, we need to know the total probability of the students that are right-handed in the first place, right? So let's say if I were to pick my first student, and if it's right-handed, what is the probability of that student that is right-handed? I'm looking for the probability first. So first pick, if it's a right hand, what is the probability? Okay, anybody wants to give it a try? That's where you have to decipher from the table. I pick from the table, it is a right hand student. What is the probability? Okay, let me give you a hint. right hand. Okay, very nice, Chen Chen. That's essentially the actual probability for both. But if I were to look at one, right hand, very good, Denise. That's actually correct because right hand, total number is how much? 33. So the first one is going to be 33 over total number of students, which is, we just add them up, add all the numbers up because male left hand, 3, right hand, 18. Plus 4, very good, Denise, plus 15. This is equals to 40. That's the first part. Okay, now let's say if I were to pick another right hand student, what is the probability? Pick another right hand student because both right hand. That means first pick and second pick. Okay, you realize I emphasize on the and. First pick and second pick. Very good. So, but next question, do I add or do I multiply? Do I add or do I multiply? Very good, Chen Chen. So take note because both left hand means first one is left hand, second one also left hand. So we need to multiply. Henceforth, answer 44 over 65. Okay, now next one, it's a little bit harder because one thing we take note is both are female. Both are female, but only one is left-handed. Only one is left-handed. So what does it mean? Okay, that means we have to look into more specific cases right now. Both female, and in this case, only one left-handed. So therefore, based on what we have, okay, both female, only one left-handed. So what are the different scenarios that can happen? So let's zoom in first, okay? Only one left-handed. Okay, so let's zoom into this case. Female, left-handed. What is the probability of picking only, let's say the first one I pick, it's a female and left-handed. What is the probability first? What is the probability? Okay, only female, left-handed. Very good. So that is the consideration. We can actually pick, firstly, one female, left-handed. But now, if I were to pick another one, what is the probability? Okay, so this is female, left-handed. If I were to pick another student, okay, Chen Zheng, you want to try? Okay, that's the first one, 1 over 10, that's good. Now, if I were to pick the next one, what is the probability? That's where I need to test you all. What is the probability? Very good, Chen Zheng, that's good to hear. Anybody else wants to try? Take note, we know the denominator is going to be 39. What is the numerator? Numerator, let's take note. I need one left hand. The left hand has been picked. The other one shouldn't be a left hand. That's right, Chen Zheng, very good over here. So therefore, 15. Okay, but is this the only case? First one left hand and right hand. Is this the only case? Do I need to consider another scenario? So take note, this is left hand first, then right hand. Can I consider the other case? Whereby I pick the right hand first, then my left hand. Again, in this case, the order matters. The order matters. So right hand, left hand. As compared to the first one, why didn't I add the other one? Because both are right hand. Right hand, or right hand, right hand. It's a repeat. But this one, there's another scenario. Female left hand followed by right hand, or female right hand followed by left hand. So you have to ask yourself, right hand, or right hand. It's a repeat. So that's why this one I didn't add again. But these two are different events. So therefore, I need to add them up. Press your calculator, 1 over 13. Okay, that's how we get it over here. Okay, that's how we get it over here. So first question tells you how to read the table. Second question, same thing, but I have to read closely into the details and see what you need to add, what you don't have to. Okay, what you don't have to. Okay, so with this question, I hope we are ready to tackle bubble question 3, similar to the previous one. Let's see how you guys will fare. Alright, launching the bubble launcher. Take note. In 3, 2, 1. More information, but let's see how you will do it. Let's go. Alright, that's good to see. Again, just more information, but the concept that we are doing, it's similar. Okay, we are selecting 2 developers at random. What are we considering? Sorry for that. Again, ask yourself, remember what I said. Do I need to consider the other scenario, or do I need to randomly permutate? Is it necessary? That's a question you have to ask. Alright, you have the last 30 seconds. Last 20 seconds. Alright, looking at the responses, looks good. Last 10 seconds. Last 5. Okay, I have a feeling that the 11 people. Alright, okay, now we have one more response. That's good. Let's see. Alright, going good. Alright, good job, guys. Okay, so you guys actually understand what I meant for that part. Again, let's look. First things first, we have our total. Yeah, let me just go through for the benefit of doubt for the rest who did not get it correct. First things first, we have to understand that, again, this is the total amount. We need to know the total first. And we do have a consensus that it is without replacement. That's the first step. Now, therefore, both developers are senior. So we are looking into the total amount over here. 253. Okay, add them up. It is going to be 10. So again, picking 2 of them. Probability that both are senior. Again, is without replacement. So therefore, first senior is going to be 10 over 20. Okay. Next one, because 19 left. How many senior left? We pick the first one, assume 9. Take your calculator, press it. That's where you have 9 over 18. 38, sorry. Henceforth, answer number 2. Okay. Those who answered the third one, take note. Remember, it is a replacement. Okay? Remember, it is without replacement. So we need to subtract 1. Okay, but good job on the first one. Good job on the first one. Give yourself a pat on the back. Let's see how we fare for the second one. Okay. Always remember positive vibes and doing good as well. Let's see how we fare for the second one. Similar notion over here, but let's see how we fare. Okay. Take a close look. Both of them are junior, but only one specializes in back-end development. So which column are we looking into? Very, very important, yeah? Launching my bubble launcher in 3, 2, 1, or in this case, do we need to consider the other option? Alright, okay, doing so well, doing so good. Again, so what we need to consider based on the question over there. If for those who do not understand what we are doing, but based on the bubble options, I think we are, I see. Sorry for the tongue twister. I think we are going good, but along the way, if you're not sure, feel free to just type in the chat and I'll try my best to answer for you. Okay, but everything is going good so far? Looking at that over there. Doing good, doing good. Remember, few things to take note. Is it with or without replacement? I believe I've mentioned that based on this statement over here. And what are we finding? One minute left. Some of you all fell into the trap, huh? So take a close look and see what we have. We have about 40 seconds for the best we have yet to answer. Hanging there with me. Alright, doing good. Awesome. Wow. I am so heartened by the response. Give yourself on the pat on the back. You guys are doing awesome. But for the rest who did not answer correctly, don't worry about it. That's where I'm gonna go through with you. Alright? Aha, I have more people falling into the trap. Okay, take note. Looking at the responses, I am heartened by the response, just that there's one additional step that most of y'all forget. I think once I mention this, you'll be like, oh, okay, I see where this is going. Okay, time is up. Let me take a look. Okay, so what happens? Let's zoom into what the question asks. Good job on the response, but let's zoom into what the question asks. Both developers are junior, sorry for that. But only one specialized in backend. Okay, so junior, let's take a close look. And I want junior, what am I trying to say? I want junior developers. Okay, so how many junior developers? And one of them must be backend. We want one backend. So let's zoom into account. Always remember, we suppose with the first one we select is the backend one. Give yourself the scenario whereby, okay, both juniors, one backend. In this case, let me just say one BE. So the first one, definitely, let's say you were to select the backend one, it's going to be number here 7 over the total number of developers. Let's take note, in this case 20. So 7 over 20 multiply by what? Multiply by, take note, okay, 3 over 19. Now why 3? Because the first one is the backend. The second one is the non-backend, because both, I'm selecting 2. So one of them has to be, the other one is not. But some of y'all, you realize, is there another situation that can occur? So you always have to ask yourself, if I flip my event the other way around, is it a repeat? In this case, if I were to do this, I select a non-backend one first, followed by my backend. Is it a repeat event as compared to the first one? In this case, it is not, because both persons are different. One is backend, one is non-backend. So if I flip it around, it's a separate event to consider. So that's where you take your calculator and press and take 221 over 90. That's how you get this option over here. Okay, so moral story is to ask yourself, first thing, whether it is without replacement or with replacement, based on this sentence. Second one, ask yourself, when I select these two events, if I flip these two around, is it a repeat? Compared to this one, if I flip this around, is it a repeat? Okay, in this case, it's a repeat because it's just senior or senior. You are repeating both events. This event, it is not a repeat because flipping it gives you two different scenarios. Okay, so I hope with this, before we go on to the possibility diagram, another feedback to check where you guys are so far, whether you are following the lesson in particular, before I move this on to the possibility diagram. Okay, we are halfway there. Okay, looking at the response, it's going good. Okay, more greens, yellows on the other side is decreasing, that's good. Let me just check accordingly. Okay, it's more or less the same scenario. Okay, so let me go on. Along the way, if it's unclear, especially the red one, that's why the red one, feel free to write it down and let me know. Okay, now next one, possibility diagram. Okay, as you guys might have seen accordingly, okay, this is my possibility diagram. Hopefully, you guys understand that this is the first option. In this case, my cards option. Sorry for that. My cards option over here. Card is randomly drawn. And a fair coin is flipped, which is the second option over here. Okay, looking at the response is going good, but on the red side one, let me know where you need help in at the Q&A. Just ask it accordingly, it will be fine. Okay, so you realize these options over here, just to recall from the possibility diagram, corresponds to this option here. So let me test you all to see whether you all understand. Can anybody tell me for this particular box over here, what is to be filled in over here? What is the particular option? Okay, so it is this one over here. So this one and this one, what is my final option I should write? Okay, give you all 1 second to think about it before we move on to the next bubble question. So I have 2, I have T. So what is the option? Very good, Denise. Very good, Chen Zhe. Any other responses? Okay, I'm seeing a string of responses. Very good. So we know this is 2 and T. So it's just looking at 2, T. Aha, I have a card that shows 2 and a flip a tail. So following the rest, okay, at the top is going to be, I have a 2, I have a head. Similarly, I have a 3 and a head. The other one, 1 and a T. So I have a 1 and a T. Next one over here, I have a 3, I have a T. So this is just to see, okay, looking at the row and column, which entry corresponds. Now with this particular recap, let's bring it up a notch. Let's bring it up a notch. Okay, looking at this, I have 2 boxes now. First box contains 1, 3, 5. Second box contains 2, 4, 6. Again, you will need to draw a possibility diagram. My recommendation to actually see the event, and we want to actually draw a card from each box. A card from each box. Okay, but take a close look. Okay, if I draw the possibility diagram, do I need to multiply anything? Okay, launching my bubble launcher. Okay, you have extra 30 seconds. Please draw it out. It's usually about 1 minute long, but because you will need extra time to draw the possibility diagram, so take your time, draw it out, launch it now. Let's go. Okay, that's good. Okay, so how will I draw my possibility diagram in this case? Before I start to draw up over here. And take a close look. This is a very typical question, and in fact, boils down from Sec 1. During exams, the teachers will like to use this. Both cards prime. What does it mean to be a prime? I need both cards to be a prime number. They like to use this trick a lot. I repeat, a lot. Okay, so you have about 44 seconds left. 1 minute and 40 seconds left. I forgot about the 1 minute, sorry. 1 minute is a lot. Sorry for that. One minute, 30 seconds left. Okay. Remember, prime. Okay, that's good. Most of my responses are there. Going good. I have about 1 minute and 19 seconds left. I still have a few more of your verbal response. I guess you'll need a hint to draw my possibility diagram. Okay, so take note, in this case, instead of 2 by 2, because there are going to be 3 options each, so that's where you have to draw all my 3 options. 1, 2, sorry if it's not symmetrical, forgive me, and 3. So my first box is 1, 3, 5. Second one is 2, 4, 6. And from there, how do we fill in the options? Okay, and from there, when you fill in the options, take note, I think the options I can fill in for you, it's gonna be 1, 2, 3, 2, 5, 2. Again, corresponding the rows and each of the columns. You can do column wise, but I recommend you do row first because it's easier to read. Similarly, it's going to be, in this case, 1, 4, 3, 4, and 5, 4. You can do it the other way around, same thing. Lastly, I have 1, 6, 3, 6, 5, 6. Now with these options, that's where what is the prime that comes in. Last 3 seconds. Okay, let's take a look now. Prime numbers, a lot of you fall into the trap. Okay, take note, by now, I hope you all realize that 1 is not a prime number. So therefore, I am going to tell you all the numbers that are not prime. This is not prime. These 2 are not prime. Henceforth, these 2 are not prime. This is not prime. This is not prime. These 2 are not prime. Okay, so these numbers are the numbers that are not prime. So you can do some notations on your side, and once you realize that the rest of the numbers are prime, and looking at the question, I want both prime. So essentially, once you get to this step over here, it is essentially just taking note of how many, where both in this case are highlighted yellow. So once we know highlight yellow already, probability that both is prime is going to be, how many options do I have? I have 9. Okay, 9 options. And for those who chose, let me just check. For those who chose, in this case, option 3, I have some of you choose option 3. Most of you all choose this. Take note, don't fall into the trap. Okay, I forgot to circle this. This is prime. Don't fall into the trap. It's 2. 1 is not a prime number. And for those who chose this, take note, I don't consider the top and bottom. These are the scenario. These are the cards given. The events are the ones that you fill in, and usually with a comma. Okay, so these are the ones. So essentially, you can do some notations at your side to know what you have to look out for. Okay, you have to look out for. Now, with this notion over here, let's move on to the next one. Henceforth, let me just circle. Answer is number 4 over here. Now, with this notion over here, let's move on. This one only 1 minute long because you have your possibility diagram there. So 1 minute long to check sum of numbers is greater than 7. Hit greater than 7. Gonna launch the bubble launcher now in 3, 2, 1. Let's go. Okay, going good. So over here, I'm not gonna ask you to draw the possibility diagram. I'm gonna draw at my side. Okay. So from here, 1, 2, 3, and from here, 1, 2, 3. So I have 1, 3, 5, 2, 4, 6. Write in all your options and see where we will fare. Last 30 seconds. Okay. Again, I'm not drawing this because I'm giving a hint, but because it should be drawn for you already. So I'm just drawing it out for easier access. 1 over 6, 3 over 6, and 5 comma 6. It's not over, it's comma. Last 10 seconds. Okay, let's take a close look. Okay, time's up. Let me take a close look. Okay, seems like this question is going very well. Just that, need to take note. When I say sum is greater than 7, it is a strict inequality. Strict inequality. Okay, because when I say greater than 7, the greater notion is as such. So henceforth, key thing, do I include 7 or not? Yes or no? Let me bring it out to the floor. 30 seconds for you to answer. Do I include 7? Yes or no? Okay, so 7, do I include it? Very good, Denise. Anybody else wants to try? Okay, Ophelia, do you want to give it a shot? Greater than 7. When I say greater than 7, is 7 greater than 7? You ask yourself this sentence, does it make sense? Like, is it weird? They are equal, right? So it doesn't make sense. Don't worry, that's where we learn together. So therefore, we cannot include 7, and henceforth, only these 3 options are chosen. Henceforth, 3 over 9. Total events 9, I only have 3 events. Simplify my probability, 1 over 3. Over here. Don't worry, Ophelia, that's where we learn together. Okay, don't worry. Henceforth, for the other options, just take note over there. Some of y'all may have missed out quite a bit. Okay, you may have missed out quite a bit, or you might have included one of these options, or you might have included both. So just take note from there. Just be very careful. Okay, just take note from there. Okay. Now, moving on to possibility diagrams, we move on to the ones that is the most tedious of all. Okay, most tedious of all. Why do I say that? Because you have to draw it very carefully, because if you were to sort of draw it wrongly, it might boil up, which is just now a possibility diagram. Last diagram to go through, free diagram. Okay, so look at the notation down there. There are, in this case, a few scenarios. In this case, the recap over here is with replacement. Okay, we are talking about with replacement. That means we replace the item. Okay, so what is the difference? So when we talk about tree diagram, picture a tree that has branches. So in math, our branches look like lines like this. you can picture this. So two scenarios, let's just recap, red and blue. Probability of getting red, can anybody tell me what is the probability of getting a red ball? Okay, you have total, both it's 9. What is the probability of getting a red ball? Okay, alright, okay, very good. I'm seeing some responses. Total, it's 9 balls, very good. And in this case for red, it's gonna be 4 and 5. Alright, okay, that's the notion. Now, tree diagram. Suppose I'm talking about, just want to branch out another tree, because why? Only 2 balls. So don't keep drawing all your tree diagrams until you have 8 branches, 15 branches. No, that's too much. 2 balls. So this is actually your first draw, because the first draw is for the first ball. And second draw, that's where we have each one coming out from each possibility. So red and blue. That's the second draw. Now, can anybody tell me, because I'm talking about with replacement over here, what will the probabilities be the same or different? So suppose, let's say I talk about red. What is the probability of drawing a red again? Is it going to be the same or different? Write down the lines over there. Same or different? I just need to know same or different. Okay, because with replacement, that means, what does it mean? If I were to draw this ball, that same ball is replaced, which means my total does not change. Henceforth, that same ball is replaced and it remains. And even so, for the blue one, it is not picked, so it remains 5/9. Similarly, if I pick a blue and I consider the next blue, that same ball is replaced and the blue ball is replaced as well. Similarly, my red does not change. Moral of the story, what have we sort of recapped from here? Remember, okay, regardless of the branches, if I were to talk about, in this case, let's look at this, in this case, with replacement, keyword is with replacement. Okay, moral of the story, if you were to listen to my explanation well, numerator and denominator does not change. Okay, does not change. Okay, so I hope you get my explanation, because when they talk about replacement, that same object is replaced. Okay, let's see whether you guys know how to fare with this question over here. Now, this question is 3 minutes long because you have to draw the tree diagram. So take the time to draw. Definitely doable if you draw a tree diagram. Okay, look at it closely. 3 green marbles, 4 yellow, and what do they want? At least 1 marble is green. Okay, take note how many branches you need to draw based on the marbles, based on how many events you are doing. Okay, launching the bubble launcher in 3, 2, 1. Let's go. Okay, that's good. Well, seems like you guys have super magical powers, yeah? Seems like you guys have super magical powers. Either you can answer this very quickly, or my explanation is fantastic, or you might have just listened to the previous lesson. Okay, but don't worry, take your time to draw the tree diagram, alright? So, how does a tree diagram look like? Refer back to the previous scenario, and let's see how you guys will fare. Okay? 1 marble, at least 1 marble is green. So what does it mean? Okay, I'll let you all count down before I draw the tree diagram. When will I draw? I'm not too sure myself. But seeing the responses, I think it's going very well. Okay, 2 minutes left. Take your time. Draw it out. Okay, so when we draw the tree diagram, when you calculate, is it plus first, then multiply, or multiply then plus, or what is the different combinations we need to consider? Some of you forgot one option over there. Be very careful. Okay, so I think most of you are done. Let me just draw and help you all. So we call tree diagram. Again, it's a recap. Green, yellow, and how many more branches I need to draw? Just one more from each event. Green, yellow, green, yellow. And what are the numbers that I need to fill in there? Okay, seems like it's going good. Okay, one more minute. Okay, based on these diagrams over here, how I remember drawing the tree diagram, okay, for those who are done, for those who are still doing, hang there. How do I remember drawing a tree diagram is this, okay? Each event, I assume is a single event, okay? Suppose I pick green. First, what is the probability? In this case, I hope you all realize, 7, 3 in the numerator, 3 over 7. Henceforth, yellow is just the other way around. The other branch you have to consider, in this case, given the situation that I've highlighted in red. In this case, it's with replacement. So therefore, with replacement, that means we call, what does it mean with replacement? Okay, remember what I said, with replacement over here is to consider that the same marble is replaced. Complement. For yellow, same thing. That same marble is replaced. Complement. And henceforth, just nice. Last 3 seconds. Look at the response going so well. Alright, so at least one marble is green. All you need to do, remember, when you want to find the event, we trace it. At least one. So it's either one marble, and some of you all miss out this. At least one is green. This is also considered. So therefore, when I talk about at least one green, at least one green. So you have to consider probability of green or GG, or just only one marble. Okay, this is where the events are. You have to permutate. So therefore, all you need to do, multiply each of the numbers. So GG, 37, 37. GY, 37, 47. Lastly, YG, 47, 37. Take your calculator, press it out. 33 over 49. Okay, that's how you got it. Okay, the other option is because you have missed out this branch over here. So that's why I have some people answering option number 2. But don't worry, that's where you know, and that's where we found out. Okay. Last thing, you realize we have gone through with replacement. What about without replacement? Okay, so over here, just to change the scenarios, I have now red balls and blue balls. Okay, so for this one, I think due to lack of time, I will still go through the bubble questions. There will be 2 more bubble questions later, but I will go through the scenarios accordingly and see how you guys fare in the bubble questions. So I have red balls, I have blue balls. What is the difference for with replacement and without replacement? First branch, no difference. It's just a scenario 4, 9, and in this case 5, 9. The difference comes in where I am picking the second draw in this case. In this case, it's the second draw. There might be 3 draws, stay tuned. 2 balls. Okay, so what happens? Okay, I have 3. I have over here. Now, without replacement, that means that same particular ball will not be replaced, which means there will be 1 ball less or 1 item less. So therefore, total items, take note, 1 item less, total reduced by 1, top also reduced by 1. Similarly, my red blue balls, the numerator does not change because I'm not picking it for the blue one. Total remains 8, but the blue remains the same because I'm not picking. Henceforth, for the blue one, consider the ones that will be affected. Total left 8, top one left 4, or we can say this is 1/2 after you have write 4 over 8. At the top, the total gets affected, the red does not get affected. So what's the moral of the story? You have to depend on the branch itself in this case over here, either the numerator or denominator. Numerator will be affected, may be affected, depending on the branch. But regardless over here, because I'm talking about replacement, the bottom is the total. So regardless what happens, it is never replaced. So therefore, denominator, in this case, will always be affected. That's one key thing over here. Okay, so the first part, depending on the branch, numerator may be affected. But for the second one, because I'm removing one item, that total is definitely going to decrease. So therefore, denominator will always be affected. So that's one way to know with and without replacement. Okay, I hope this helps. And let's see how we fare for the last two bubble questions. So the last two, okay, again, is to see from the previous tree diagram that you have drawn. It's the same question. From the previous tree diagram that you have drawn, how do I alter the tree diagram? And how do I solve? Based on the question. Alright, launching my bubble launcher in 3, 2, 1. And because the next one is going to take quite long, so I might exceed the lesson by a little bit. But I hope you guys do understand based on this question over here. Okay, so take note of the key point over here. Without replacement. And exactly one of them is yellow. Alright, I have my first response, that's good. Exactly one is yellow. So how does my tree diagram get affected over here? Take note, it's without replacement. If you follow my pointers at the top, it should be okay. And I want exactly one marble. Okay, that's good. Seeing the responses streaming in heartens my heart as well. But don't worry for the rest. Hang in there. You can do it. Always remember, always have a positive mindset when you do stuff. It will help you a lot. Alright, going good. Okay, so again, I'll just wait a little while more before I draw the tree diagram for those who need the help. Okay, for those I have actually, let me just check. I've actually quite some Sec 2 or even a Sec 1 student there. Okay, so for that, I hope you can follow for the Sec 1 student. But if you just try your best to follow, but for those who are Sec 2 and above, try to follow as well, even though it's a sense of probability, because this concept is actually a Sec 4 base, what we are going through now. So just hang there, 1 minute left, let me see your response. Alright, that's good. Take note, this is without replacement now. So what happens to my numerator and denominator depending on the scenario? Okay, so I hope you got tree diagram is going well. 2 marbles. Green and yellow, green and yellow. Okay, if you follow my tip, this question should be alright. Okay, hang in there with me. Last 30 seconds. Alright, seeing the responses. Okay, very nice, very good. Okay, very good. Okay, looking at the responses, I'm heartened. Just some little mistakes that you might have to take note. Last 10 seconds. Last 5, 4, 3. Alright, you guys are doing so well. Give yourself a pat on the back. And from there, let me go through this quick. Okay, so from here, first one, green, we know is 3 over 7. White, in this case, it's 4 over 7. Next one, what happens? Okay, replacement is without replacement. So therefore, remember what I said? Total items is gonna reduce by 1, definitely. But for the top, is it gonna get affected? I pick a green. So green reduces by 1. Yellow remains the same. In this case, yellow reduced by 1. Green stays the same. So therefore, all you need to do, once you fill in the numbers, trace it out. Okay, trace it out. And fill in what you need. Exactly 1 yellow. Okay, so that's where some of you may either have missed out one event, or in this case, do with replacement. So without replacement, take note. Exactly 1 yellow. So in this case, with 1 yellow is exactly, in this case, green, yellow, or yellow, green. Which is in this case, 3, 7. All you need to do next, plug in the numbers, 3, 7, multiplied by 4, 6, because it's green, yellow, so it's N, or yellow and green. So remember the keywords, N is to multiply, or is to add. Okay, add this in, that's where we have 4 over 7. Okay, that's one part. Okay, lastly, I know we are reaching 3, but I have one more bubble question, and I think we can do this together. So let's finish off with this tedious event 4 as such. So this is a little bit tedious. Look at it very carefully. First sentence will make a lot of difference, but let's see how you would fare with the same context, but just that this sentence, and now even harder, I have 3 marbles. Oh my god, how do I draw this? Launching it now, last bubble question for today. Let's do this together. 3, 2, 1, that's why you have 4 minutes. Let's go. Okay, I'll exceed this quite a little bit, I'm sorry, but along the way, I'll probe you all along. Okay, the tedious part is the yellow marble is now replaced. So what happens? And 3 marbles are drawn. Then, oh my god, how will my tree diagram look like? I'll give you all some time to try, okay? Okay, very nice. I have my note. Take note. It's, again, what's the keyword? Without replacement. So how does that follow up? For 3 branches. Okay, so follow the same concept. Just now the recap was only 1 branch, 2 branch. But if you follow the same logical process as we talked about without replacement, from the second branch, if I were to pick out one more time, how does that affect my numerator? How does that affect my denominator? Very important. Okay, it's going to be quite some layerings over there. This is a little bit hard, tedious over there, but I believe you guys can do it. Okay, 2 minutes left. So let me just draw the first 2 branches. These 2 you should be familiar by now. Okay, so I have green, yellow. Okay, this is for 2 marbles, all right? 2 marbles. I will need to draw it this way. But now 3 marbles, how will it look like? It's going to be a little messy. I agree, it's going to be a little messy. Okay, 2 minutes left. Hang in there with me. Again, the first one should be fine, but because of this sentence, how will this get affected? Again, quite some hints over there. You have to understand, take note, the first sentence affects your probability by a lot. And the sentence over here. Okay, this one, I think that's where a lot of people struggle a lot. Okay, so third one is just branching out again. Let me draw some hints over here from this side. And now the hardest part is, how do I fill in the numbers? Okay, just picture this. It's just a lot of different scenarios. Okay, but I see a lot of options streaming in. 1 minute, 30 seconds left. So this is the highest part of the question for they can go by. Maximum 3 branches, okay? Definitely not 4, because you can understand how extensive your tree is going to be if it's 4 branches, yeah? You're going to have 2, 4, 8, 16. So that's actually going to be 30 branches drawn, which is, I don't think what they're going to go for. Okay, so don't worry about that. But take note, the main purpose, the main concept of without replacement, keyword without replacement, comes into play. Okay, follow the without replacement. 43 seconds left. Just stay with me. We're almost there. Okay, I'm seeing the options coming in. Last 30 seconds. Hang in there with me. I know it's a tedious question, but once you get the numbers right, the rest of the concept is all there. Last 15 seconds. Last 10. All right, that's good. That's good. Okay. Last 4. Okay, this question I can see a lot of people struggle a lot, so I'm gonna explain this and we'll call it a day for today. So the first one, take note, a yellow marble is replaced with a green marble. So what happens? One yellow marble is taken out, so I have 3 yellow left, and it's replaced with a green marble. So 4 green, 3 yellow. So therefore now, this sentence over here is actually render useless. We are following this one now. So with this first branch of picking a green, it's going to be 4, 7, 3, 7. And again with the other 2 branches, again, numerator definitely will decrease by 1 without replacement. 6, 6, 6, 6. But what is the number? Take note. Green, it's picked up. 1 less green. Yellow remains for this scenario. So it's going to be 3. Similarly, for the second branch, yellow is picked up. So it's going to be, in this case, 3 yellow. No, sorry, 2 yellow. Sorry for that. 3 minus 1, 2. My green marble, not picked up. So it's going to be 4. But now for the rest, how do we do this? Similar scenario. Regardless of the scenario, each of them will get reduced by 1. So 5, 5, 5, 5. Okay, numerator, denominator will stay the same. 5 throughout. Again, depending on the scenario, green gets picked from green, so it's reduced by 1. Yellow remains the same. So 3. Again from here, yellow gets picked up, so it's going to be 2. Green remains the same. It's not picked from here, so it's going to be 3. Okay, rest of the numbers, follow this notion, you will get it down. Again, green gets picked. I have left 3. Yellow does not get picked. It remains at 2. Last one, yellow gets picked. I only have 1 yellow left. Green is not picked. I have 4. Follow this scenario. Once we have that, 2 out of the 3 marbles are green. 2 only. So it's going to be green, green, yellow, and as well as green, yellow, green, and I have yellow, green, green. Any others? Yeah, we are done. So therefore, all we need to do, sum of them up, 2 out of 3. So the hardest part you realize for this question is not the deciphering, but how you fill in the tree diagram. Once you have this, all you have to do, probability of green, green, yellow, or all the branches I've highlighted essentially. Once you have that, write it out. Fill in my numbers. So in this case, it's quite some multiplication to be done. 4, 7, 3, 6, 2, 5, and so on. 4, 7, 3, 6, and 3, 5. Take note of the branches you're multiplying. Plus last one, 3, 7, 4, 6, 3, 5. That's where your extensive calculator skills comes into play. Add them up, you have 18 over 35. So all you have to do, you realize the technique actually comes in more from filling of the tree diagrams. Not really of, and the branches following, not really of how hard is it to decipher. It's more of the tediousness. And with that, that's actually what I have for you today. You ever try yourself in this case? Give it a shot. It's a very interesting question. Give it a note to see how you decipher this question. 30 marbles up for 30 marbles. Did I say marbles? 30 bubbles up for grabs. Okay, it's a very different variation of the question that it comes about. And the tip of the day. Okay, whatever I've said. When you determine the possible outcomes, always ask yourself, if I switch the order, is it making a difference? So 1 green, 1 yellow in this case. Okay, the order does not matter. But green first, yellow second, it has to be that certain order. Green first, yellow second. So that's why this one cannot consider. Or in fact, when I switch the draw, is it a repeat event? Which I've mentioned. With that, that's it for today. So take note of the recaps that we have done of the possibility tree diagrams with and without replacement, especially the case. And yes, thank you for the note moderator. If you have any questions, feel free to ask me. Otherwise, thank you for staying with me. I apologize if I exceeded for quite long, but I feel it is important to go through every one of them. With that, stay tuned next week. Until then, it's Teacher Jason signing off, and I'll see you then. Alright, thank you. Bye-bye.